In this video, we will be dealing with the numericals of mole concept. We will take different cases and use the concept of mole. So the first problem is to calculate the mass of an atom of silver and a molecule of carbon dioxide. So let's begin. We know that the mass of a silver atom is equals to 108 U. Therefore, we can say that 1 mole of silver is equals to 108 gram, or we can say that 1 mole of silver is equals to 6.02 into 10 to the power 23 atoms. Therefore, 6.02 into 10 to the power 23 atoms of silver have mass equals to 108 gram. Therefore, 1 atom of silver is equal to 108 divided by 6.02 into 10 to the power 23, which is equals to 1.79 into 10 to the power minus 22 gram. So next, number 2, the mass of a molecule of carbon dioxide. So the mass of a carbon dioxide molecule is equals to 44 gram, or we can say that 1 mole of carbon dioxide is equals to 44 gram, or 6.02 into 10 to the power 23 molecules. Since we are talking about molecules, that is the carbon dioxide, so we will take it as 6.02 into 10 to the power 23 molecule. Now this 6.0302 into 10 to the power 23 molecules of carbon dioxide will have a mass of 44 gram. Therefore, 1 molecule of carbon dioxide will have a mass of 44 divided by 6.02 into 10 to the power 23, which is equals to 7.307 into 10 to the power minus 23 gram. So in this problem, we have to calculate the number of atoms of the constituent elements in 53 gram of sodium carbonate. So first of all, we need to calculate the gram formula mass of this compound. So the gram formula mass will be equal to, since there are 2 sodium atoms, so it will be equal to 2 into 23, that is the mass of sodium, plus carbon, mass of the carbon 12, plus the mass of 3 oxygen atom, that is equals to 3 into 16, so it is equals to 106 gram. So now we can write as 106 gram of sodium carbonate is equals to 1 mole. But in the question it is given to find the number of atoms in 53 grams of sodium carbonate. So 53 grams of sodium carbonate will contain 0.5 mole of sodium carbonate. But 1 mole of sodium carbonate contains 1 mole of sodium carbonate contains 2 mole of sodium, or we can write it as 2 into 6.02 into 10 to the power 23 Na plus ion. So 0.5 mole of sodium carbonate will contain 2 into 6.02 into 10 to the power 23 into 0.5 sodium ions, which will be equal to 6.02 into 10 to the power 23 Na plus ions. So 1 mole of sodium carbonate contains 2 mole of sodium, or we can write as 2 into 6.02 into 10 to the power 23 sodium ions. So 0.5 mole of sodium carbonate will contain 2 into 6.02 into 10 to the power 23 into 0.5 sodium plus ions, which will be equal to 6.02 into 10 to the power 23 ions. So this is the number of Na plus ions. So next, 1 mole of sodium carbonate contains 1 mole of carbon, or 6.02 into 10 to the power 23 carbon atoms, or therefore 0.5 mole of sodium carbonate contains 6.02 into 10 to the power 23 into 0.5 carbon atoms, that is equals to 3.01 into 10 to the power 23 carbon atoms. And next comes the number of oxygen atoms. So 1 mole of sodium carbonate contains 3 moles of oxygen, or 3 into 6.02 into 10 to the power 23 oxygen atoms. Therefore 0.5 mole of sodium carbonate will contain 3 into 6.02 into 10 to the power 23 into 0.5 oxygen atoms, which is equal to 9.03 into 10 to the power 23 oxygen atoms. Thus, we can say that 1 mole of sodium carbonate contains 6 into 0.2 into 10 to the power 23 sodium ions, 3.01 into 10 to the power 23 carbon atoms, and 9.03 into 10 to the power 23 oxygen atoms. So in this problem, we have to calculate the number of atoms in each of the 3 cases. Number 1 is 52 moles of helium. Number 2 is 52 unit of helium, and number 3 is 52 grams of helium. So let us first deal with number 1, that is 52 moles of helium. We know that 1 mole of helium is equals to 6.02 into 10 to the power 23 atoms. Therefore, 52 moles of helium will be equals to 52 into 6.02 into 10 to the power 23 atoms, which is equal to 3.13 into 10 to the power 25 atoms. So this is the first case. Next, number 2, 52 unit of helium. We know that 1 atom of helium is equals to 4 unit of helium, or we can write it as 4 U of helium, that is atomic mass unit. 4 atomic mass unit of helium is equal to 1 atom of helium. Therefore, 52 atomic mass unit of helium will be equal to 1 by 4 into 52 atoms, which is equals to 13 atoms. Therefore, 52 atomic mass unit of helium contains 13 atoms. And last, number 3, that is 52 grams of helium. We know that 1 mole of helium is equals to 4 gram, or we can write as 6.02 into 10 to the power 23 atoms. Therefore, 52 gram of helium will have 6.02 into 10 to the power 23 divided by 4 into 52 atoms. So it will be equal to 7.8 3 into 10 to the power 24 atoms. So let's summarize it once again. So 52 moles of helium will contain 3.13 into 10 to the power 25 atoms. 52 atomic mass unit of helium will contain 13 atoms, and 52 gram of helium will contain 7.83 into 10 to the power 23 atoms.